Hey, let's learn some brand new derivative shortcut rules. Today, we're going to work with the product rule and the quotient rule. And toward the end of the lesson, we'll also talk about higher order derivatives. So let's start with the product rule. Whenever you are multiplying a product of f of x times g of x, a product of two functions, and you want to find the derivative of that product, then you say f of x times g prime of x plus g of x times f prime of x. So the first function times the derivative of the second plus the second function times the derivative of the first. These can be reordered because it's a sum. Notice that on this second row that I have put the g of x f prime of x first and the f g prime second. There's a reason I'm doing that. And I think it's going to, number one, help you memorize this rule and the quotient rule together, but it also allows me to give you a little jingle that's more memorable. Now, some people will express the product rule as a product of u times v, where it's understood that both u and v are functions of x. So instead of saying f of x g prime, g of x f prime, here I'm going to say, instead of g of x f prime, I'm going to say v u prime plus u v prime. While that's not more memorable, let's look at u prime as the derivative of u. And instead of saying derivative of u, let's say du. Then I can say the derivative of uv is v du plus u dv. And suddenly that's a little more memorable because it's got a jingle. To know which one comes first, v du, very droopy underpants. It's silly, but sometimes the jingles and the silly stuff is what helps you remember things. So let's practice some problems. All right, for our first problem, we are going to find the derivative of the product of y equals x squared and y equals e to the x, two different functions. I could say then that x squared is my u function, e of x is my v function. So to find the derivative, to find p prime of x, I'm going to say v du. Du is the derivative of x squared, which is 2x, plus u dv. Remember, we learned when we were experimenting with the calculator that the derivative of e to the x is e to the x. Now, this answer is fine, but normally you're going to see two different alternate versions. One is that people will simply factor out the e to the x and say times 2 to the x plus x squared, or times x squared plus 2 times x, so that they're putting the polynomial function in its standard form. This is typically the way I will write it. Now, sometimes you'll see people take it a step further and say x can factor out of x squared 2x plus 2x. So I'm going to say the GCF is x e to the x times x plus 2. Both of those are just fine. Now we're going to look at throwing in a trig function. Sin x will be our u, and 5x to the third plus 6 will be our v. So we'll have to recall what we learned when we were experimenting with the calculator about the derivative of sin x. But let's start first and say, okay, v is the polynomial function, du. Do you remember what we got as the derivative of sin x? If you just answered cosine x, you are spot on. Plus u dv, the derivative of 5x cubed is 15x squared. The derivative of plus 6 is 0, so I'm not going to say plus 0. Now, again, your answer is fine. A lot of times you will see people, when you've got a mixture of polynomial and trig functions, you'll see people front load the polynomial function. And so instead of saying sin x 15x squared, they'll say 15x squared sin x. So putting the polynomial function first and the trig function second. Let's try another one. So my message to you on this one is don't overwork it. Let's not overdo it. So first of all, some of you might feel more comfortable if you're going to take the derivative to rewrite it as 6x to the 1/2 power. Now, sometimes we overwork things and we look and say, well, it's 6 times the square root of x, so I need to use the product rule. And we say that u is 6 and v is the square root of x, or x to the 1/2. Then when I'm doing the derivative of k of x, I say v du. Well, the derivative of u, the derivative of a plane number, is 0, plus u, which is 6, dv. The derivative of square root of x, or the derivative of x to the 1/2, is 1/2 x to the negative 1/2 power. Parentheses not necessary there. So let's clean up. Square root of x times 0, zero's out. 6 times 1/2 is 3. X to the negative 1/2 is 1 over x to the 1/2, or 1 over square root of x. So k prime of x is 3 over square root of x. Now, my suggestion is that you not make it that hard. 6 is a constant. It's not actually a function of x. So the product rule is not necessary. It would be easier to say k prime of x is simply 6 times the derivative of x to the 1/2. 6 times 1/2 is 3. X to the 1/2 drops to the bottom. X to the negative 1/2 drops to the bottom as x to the 1/2, or square root of x. Now look how much easier that was. So don't overdo product rule when one of the functions is actually just a number. Closely following the last example, sometimes we use the product rule when we don't have to. So let's take a look at this one. A lot of people will go, oh, it's a product of 2 items, and they'll instantly think product rule, where the first binomial is u and the second binomial is v. So when we do h prime of x, we're going to say, well, the product is v du. The derivative of u is 2 times the derivative of x to the 1/2, which is 1/2 x to the negative 1/2, plus the derivative of 3, which is just 0, plus u dv. dv is the derivative of 4x, which is just 4, minus 8 times the derivative of square root of x, which is again 1/2 x to the negative 1/2 power. Let's clean that up. So I have 4x minus 8 square root x. 2 times 1/2 here is just 1 x to the negative 1/2. So 1 over x to the 1/2, or 1 over square root of x. And you can operate with x with fractional exponents or using radicals, either way. Plus, here I'm going to have 2 square root of x plus 3. Let me see if I can get that where it's less glare for you. You're going to have 4 minus 8 times 1/2 is another 4 over x to the 1/2, or 4 over square root of x. Let me condense and make that look a little bit better. Now we're still not clean. We need to distribute here. So 4x times 1 over the square root of x is going to be 4 square root of x. So remember, 4x to the understood 1 or 2/2 power over x to the 1/2 power. You're just going to subtract and say 2/2 minus 1/2 is x to the 1/2, or 4 square root of x. So just using your rules of exponents there. Minus 1 over square root of x times 8 square root of x is going to be minus 8, because the square root of x's will cancel top to bottom when you multiply. On this part, we're going to have to FOIL. So 2 square root of x times 4 is 8 square root of x. 2 square root of x times negative 4 over square root of x is negative 8. And again, the square root of x is canceled, so just minus 8. 3 times 4 in the middle is 12. 3 times negative 4 over root x is negative 12 over square root x. Let's combine like terms and finish this one up. So I'm saying 4 square root of x plus 8 square root of x is 12 square root of x. Negative 8 and negative 8 is negative 16, plus 12 is negative 4, minus 12 over square root of x. That's a good answer. We'll stop there. Now, I'm suggesting on this one, we could have made this simpler. So instead of using the product rule, what if I just FOILed from the beginning? So at this point, I'm not doing derivative. I'm just cleaning up the given problem. So 2 square root of x times 4x is 8x to the 3/2 power. Again, 2 square root of x times 4x is 8. X to the 1/2 times x to the 2/2. Add exponents, get x to the 3/2. Now we have to do outer. So 2 square root of x minus 8 square root of x will be minus 16. Square root of x times square root of x is just x. In the inner, plus 12x. Last, minus 24 square root of x. Hey, I notice that h of x can be rewritten as 8x to the 3/2 minus 4x if I combine middle terms, minus, and I tell you what, since we've got this x to the 3/2, I'll go ahead and write that x to the 1/2 just for simplicity. Now, I don't need product rule anymore. I can just use power rule 3 times. So I'm going to say 3/2 times 8, x to the 3/2 minus 1, 3/2 minus 2/2 is 1/2. The derivative of negative 4x is just negative 4, minus 24 times 1/2 x, 1/2 minus 1 is negative 1/2. Now let's clean. So 2 goes in the 8 4 times, 3 times 4 is 12, x to the 1/2 or square root of x. You can leave it x to the 1/2 if you want. Minus 4, minus 24 times 1/2 is minus 12 over x to the positive 1/2 or over square root of x. So now I have the same answer that I got before, but it was easier. So my suggestion is don't use the new derivative shortcuts if you don't have to. If you can go back to just power rule, do that. So in general, in calculus, if you can take care of something with a water gun, don't get out a cannon. And you'll see that over and over again throughout the course. Now we're switching to quotient rule. So whenever you have a quotient of functions, f of x over g of x, then we want to take the derivative using the rule g of x f prime minus f of x g prime all over g of x quantity squared, which is g of x times g of x, but you'll see it written oftentimes as g squared of x. Now, that doesn't have much of a ring to it, makes it hard to memorize. So if instead of f of x and g of x, I use u and v, then gf prime becomes v du minus fg prime becomes u dv all over v squared. So now I'm starting with very droopy underpants again, just like I did with the product rule. So since I knew I was going to do v du here, and order matters when you're subtracting, that's why I reversed order on product rule. So both times you're starting with v du. Product rule, you say plus udv. Quotient rule, you say minus udv. Now, v squared doesn't have as much of a ring to it. So sometimes some people might memorize it as v du minus udv all over vv. So just again, jingles make it easy to memorize. Now, there's another way, and I call this the yodeling method, that you can memorize the quotient rule. And a lot of people like this way. So if you want the derivative of a high function over a low function, then you can say low d high minus high d low over low low. So low d high is the same thing as v du. So bottom function times the derivative of top function minus top function times the derivative of bottom function all over bottom function squared. Let's do some practice. All right. So P of X has an upper function, y equals 5x minus 2, and a lower function, x squared plus 1. I cannot factor and reduce this function to do anything simpler with it. So I need the quotient rule. So to find P prime of X, I'm going to say low D high, derivative of top is just 5, minus, you got to remember that minus, high, use your parentheses so you don't mess up your signs, D low, derivative of bottom is 2x, all over low, which is x squared plus 1, quantity squared. In general, we do not square the bottom if it's a binomial, trinomial, or larger. If it's a monomial, you might clean it up when you square it, but not with something larger. You can do it, but it just takes time and that doesn't actually make things better for you. What I do need to do is clean up top. So I'm saying 5x squared plus 5 when I distribute. On the top, let's see, 2x times 5x is 10x squared times the negative. 2x times negative 2 is negative 4x times a negative. So I'm thinking it swaps back to positive 4x. All over bottom squared. And that's going to be negative 5x squared plus 4x plus 5. It is not unusual that you get something on the top that does not factor and it's not real pretty. Sometimes this might factor, but it's not real common that it always will. Let's try another one. Here again, Q of X is a top function over a bottom function. There is nothing I can do to factor, reduce, or otherwise simplify what I'm given. So to find G or Q prime of X, I'm going to need quotient rule. So here we go. Low D high. Oh, derivative of top. The derivative of 5e to the x is still 5e to the x. The derivative of plus 2x is plus 2. Minus high D low. Derivative of bottom is derivative of e to the x. The derivative of -1, of course, zeroes out. All over low. It's the flow rider moment of the day. All right, so we need to clean top just like we did last time. So e to the x times 5e to the x is 5e to the 2x, because when you multiply, you just add exponents. Outer is plus 2e to the x. Inner is minus 5e to the x. Last is minus 2. All right. Here I'm going to distribute. 5e to the x times e to the x is 5e to the 2x, but I've got a minus sign, so minus 5e to the 2x. And then I've got 2x e to the x, nothing happening there. And I've got that minus sign, so it's going to be minus 2x e to the x. All over low. So I can get the top cleaned a little bit. Notice 5e to the 2x minus 5e to the 2x cancels. 2e to the x minus 5e to the x is negative 3e to the x. Minus 2. And then I've got minus 2x e to the x. Not real pretty, but manageable. So e to the x minus 1 squared. Now, one thing that I'm not showing you on this video, but at this point, if I said, okay, find the slope of the tangent line at 0, all right, you would say from here, go ahead and say Q prime of 0 is negative 3. E to the 0 would be times 1. Minus 2 minus 2 times 0 is 0 times e to the 0 is still 0. So I don't need that. All over. E to the 0 is 1 minus 1. 0 squared 0. So that wasn't a great problem. But the point was, this I would not give you because it's undefined. But the point is that even though I'm not asking you to find the slope of the tangent line or write the equation of the tangent line, you still, even though we've got more complicated derivatives, you can still just plug in and do what you need to do to find the numerical value of the slope. Plug in up here, do what you need to do to find the numerical y coordinate, and then you'll take your point and your slope and go to point slope form. Now, I'm not going to work this whole problem, but if I ask you to do m of x, don't burden yourself, m prime of x. Don't burden yourself with worrying about 1 over x being x to the 1, -1, and then -1 over x squared. You're going to make it harder on yourself if you do that. So my message to you is don't start quotient rule till you clean this guy up. So you can either make this 3x over x minus 1 over x and do it that way. Or remember, if you simply multiply your fraction by 1, distribute 3x minus 1 over, distribute on the bottom, x squared plus 5x. The top, I said 3x minus 1 and wrote 3x minus x. Sorry about that. Now do the quotient rule, and it would look a lot like our first example, p of x. Now let's look at not overworking problems. So when I rolled out the product rule, we talked about a function y equals 6 square root of x, and we talked about not looking at 6 like it was a function because it's a constant. So product rule not necessary. Same deal, pickles. Right here, product rules not, or quotient rules not necessary, but a lot of people will take off and start doing it. Let's examine that. So k prime of x equals low d high minus high d low, the derivative of the bottom 0, all over low. That gives you 6x squared minus 0. So just 6x squared on top over 4. And that gives you 3x squared over 2 or 3/2 x squared. Either one of those is appropriate. All right. What would have been easier instead of doing the quotient rule? And we all make, sometimes we all blow something out of proportion and make it too big a problem. But if you will look at k of x as 1/2 x to the third, that is way easier. Then it's just a product and power rule problem. So 3 times 1/2, 3/2 x to the second power. That is so much easier. In that same vein about not overworking a problem, earlier we worked a problem similar to this. I've simplified it, but I said, okay, if you have something that you could just FOIL first, and then you could avoid using the product rule, instead you could just use the power rule, that really is better. It's going to be easier on you. Well, that's an issue with a of x. If you look at b of x, there's nothing. If I distributed 4x squared sine x minus 1 sine x, I would still have to use the product rule right there. So on b of x, I can't get around using the product rule. So I'm just going to use the product rule from the get-go. On a of x, I can get around the product rule. So I'm going to. Again, don't use a cannon if you can take care of the job with the water gun. Well, this h of x problem is similar. So I'm going to go, oh my goodness, I noticed that you have an STD here. That's right, a single term denominator. So I'm going to show you the difficult way to deal with that and the easier way to deal with it. Okay. So if you have, if you want to find h prime of x and you're not thinking, you might launch into the quotient rule. So low d high, derivative of top looks like 10x plus 6 minus high d low, the derivative of bottom is 3x squared, all over low. Now, low here is a monomial squared. In this case, I'd go ahead and clean it up. If it's a bi or tri-squared, I don't. I just leave it as that item squared. So let's see here. I'm going to clean the bottom and the top. So top, it looks like I need to do what? 10x to the fourth plus 6x cubed. That's going to be minus 15x to the fourth. Here I'm going to have what? 18x cubed, and there'll be minus 18x cubed. Here I'm going to have minus 3x squared, but I've got to change it to plus 3x squared because it's the negative of that whole product, all over x to the sixth. All right, so h prime of x equals, let's see, it looks like I've got negative 5x to the fourth. 6x cubed minus 18x cubed is minus 12x cubed plus 3x squared all over x to the sixth. Now, multiple things you can do at this point. Hopefully you will recognize all 3, 4, if you look at the term on the bottom as being a fourth term, they're all divisible by x squared. You could factor in x squared out of the top and reduce the x squared on top with the x to the sixth on the bottom. You can also separate and reduce and write that negative 5x to the fourth over x to the sixth minus 12x to the third over x to the sixth plus 3x squared over x to the sixth. That's going to be, let me put you back on screen here, negative 5 over x squared when I'm just using basic rules of exponents and keeping exponents positive in final answer, minus 12 over x cubed, and then plus 3 over x to the fourth. Again, I could have written this as a single fraction, but in reduced format. I'm writing it in this format because I want you to compare methods, okay? Now, here is the easier way to work this problem. So again, anytime you wind up with an STD, that is single term denominator, there is no reason to keep the original problem as a quotient because I can separate just like I did on the end of the last problem. And reduce. So remember, right now I'm still just writing h of x. So I'm going to be real careful with my labels. Now I'm going to make that 5x to the negative 1 because I'm about to do the derivative and I don't want the x on the bottom. Plus 6x to the negative 2 minus 1x to the negative 3. So I've written it in derivative ready power rule format. Now I'm switching to power rule, taking the derivative. So negative 5x to the negative 2 minus 12x to the negative 3 plus 3x to the negative 4. Write your final answer without negative exponents. So negative 5 over x squared minus 12 over x cubed plus 3 over x to the fourth. And there we go. I hope that's the exact same answer we got a second ago. I didn't check. But again, if you don't have to whip out the product or quotient rules, don't. Stick with just basic power rule. All right, pause the recording if you need to. Find your concepts worksheet as listed above. And we are going to look at problem 1 because it's got some great problems where you read from the table of values. Get that, and we'll do A and C together. And then I want you to try B, D, and G, and I will give you the answers to B, D, and G after you've tried them. All right, so using a table of values, let's find some derivatives. So the first problem is saying find the derivative of 2 times f of x, and then to plug in x equals 2. So I'm going to rewrite it h of x equals 2f of x. And then I can say, well, my first step is to find h prime of x. Well, guys, if I'm wanting the derivative of a number times a function, I just say it's the number times the derivative of the function. That's all. Don't overdo it. Again, no need for product rule because 2 is not a function of x. 2 is just a number. All right, so if I want h prime of 2, I need to do 2 times f prime of 2. That's 2 times. F prime of 2 from the table is a third. So I have 2/3. Now, let's look at problem C. Problem C is straight up asking you to find the derivative of a product of functions, hence product rule. So here we go. I'm going to say the derivative is v du plus u dv. I think this one asks you to evaluate the derivative at x equals 3. So I'm going to say g of 3, f prime of 3, plus f of 3, g prime of 3. All right. Pull values from the table. So g of 3 is -4. F prime of 3 is 2 pi. Plus f of 3 is 3. G prime of 3 is 5. So I'm getting -8 pi plus 15, or you could write it 15 minus 8 pi. Now, can you do similar problems on B, D, and G? Pause the video and then come back and check your answers. Here are your answers for B, D, and G. If you need to, pause the video and look at what I did to work them out. So h prime of 3 is 2 pi plus 5 on B. H prime of 2 on D is 37/6. You got to reduce 74/12. And H prime of 3 on G is negative, sorry for that, you got the glare there, -5/16. All right, getting back to some basics, let's look at notation. So this is just an addition to power rule essentially today. Let's look at higher order derivatives. So not just the first derivative, which we show as f prime of x, if we're talking about the derivative of f of x, but the second derivative, f double prime of x, the third derivative, f triple prime of x, or you'll begin to see, because it gets a little hard to read when you have all those little tick marks up there. So you'll see f to the third of x, but if it's in parentheses, it doesn't mean to the third power. It's saying third derivative. So the fourth derivative would be f to the fourth in parentheses of x. Let's do a couple of practice problems. This is simple. With polynomials, finding higher order derivatives is simple. It's not going to be a problem at all. So first derivative, like if I ask for the second or third derivatives, you have to find the first and second derivatives first. So I tell you what, I'm going to make these numbers a little smaller so we don't have to worry about looking at a calculator. So we'll say 3 right here. So the first derivative is just going to be 6x to the 5th minus 10x to the 4th plus 27x squared. Now I go from there, and to get the second derivative, I do the derivative of the first derivative. So 30x to the 4th minus 40x to the 3rd plus 54x to the 1st. Then if I want the third derivative, I simply do the derivative of the second derivative. So what is 4 times 30 is 120x to the 3rd minus 120x squared. The derivative of 54x is 54. And then if you wanted the fourth derivative, what is 3 times 120? 360x squared. 2 times 120 is 240. X to the first power. And then of course, at that point, 54 zeros out. So it's not hard to do higher order derivatives. Consider if I ask you to do the third derivative, we'll say of r of x equals 3 over x. You may want to write this in a more derivative ready format. So r prime of x equals -3 x to the -2. Now, technically, you should say that's -3 over x squared if all I'm asking you to do is r prime. But if I ask you for r double prime or r triple prime, don't clean it up, just keep going. So r double prime of x is going to be what? +6 x to the -3. And then our triple prime of x is going to be -18 x to the -4th. And then you can go, okay, that's my final answer. Let me put that in the no negative exponents final answer. All right, guys, you've done a great job. I hope that you've understood this. I want you to go ahead and practice A11, and then tomorrow we'll do lots of practice before the quiz.